Okay, so we'll have a look at this question. We want to show that n squared plus n is always divisible by 2. And look, I always like picking a random number that isn't in my proof just to see. So I'm going to put in n equals 6. 6 squared plus 6, so n squared plus n is 6 squared plus 6. And that's 36 plus 6. 36 plus 6 is 42. 42 is divisible by 2. So I like just picking a random one so I can get an idea of what the nature of this question is, and then we'll go back and we'll actually just do our proof by starting and showing that it is true. So we're going to show that it is true for n equals 1. So we have n squared plus n, well that's 1 squared plus 1, that's 1 plus 1, which is 2, and clearly 2 is divisible by 2. Okay, then we are going to assume that it's true for n equals k, so assume true for n equals k, and so if I subbed k in for n, I get k squared plus k, and I'm just going to write down that this is divisible by 2. Now what I'm trying to prove is, I need to prove, so prove that it's true for n equals k plus 1. So if I replace the k with a k plus 1, and that's squared, and then replace this k with a k plus 1, I'm trying to prove that this is divisible by 2. Now what I want to do is I probably just want to tidy this up a little. So this is going to be square. The first is k squared twice the product, which is 2k, plus square the last, which is 1 plus k plus 1. And actually I'm going to come over here and tidy that up, and I want to show that k squared plus, you know what, I'm going to leave it like this. There's a reason I'm going to leave it like this. I want to show that this here is divisible by 2, and I'll explain the reason why I'm leaving it like this in a second. Okay, so how do we start the actual proof? So the proof, we always return to the assumption. So the assumption was that k squared plus k squared plus k is divisible by 2. Well, that means that it's equal to 2 times something, and we just call the something m. So m just represents some number. K squared plus k is divisible by 2, so it's equal to 2 times something. I'm just going to underline that. Now, you could manipulate this at this point. I'm just going to leave this here for now, and I'm going to go back to the line that I'm trying to prove. I'm trying to prove that k squared plus 2k plus 1 plus k plus 1. So k squared plus 2k plus 1 plus k plus 1. And I'm fully conscious that I could have tidied this up a bit more, but I'm just going to prove that this is divisible by 2. The way I'm going to do it is, well, I can see here that k squared plus k is 2m. Here's a k squared and here's a k. So I'm going to replace them with 2m. So that k squared plus k is now 2m. Now what else have I got in the question? Well, I have plus this 2k, and I have plus 1, which is plus 2. Now, I'm trying to prove that this is divisible by 2. Well, here we have 2m plus 2k plus 2. 2 is a common factor there. So it's 2 on m plus k plus 1. So clearly this is divisible by 2. And then we have to just finish off with our statement that we've shown it's true for n equals 1. If it's true for n equals k, then it is true for n equals k plus 1, and therefore true for all natural numbers. And that's the proof. Now, just come up here for a sec, because we've done some of these ones with indices, and when we have indices, oftentimes in our assumption, and this is our assumption here, remember, we isolate one part of it. I didn't bother isolating any here because I kind of knew that I was going to have a k squared and a k in the thing I was trying to prove. But let's isolate, let's say, the k squared. We could say that k squared is equal to 2m minus k. And then if I return to this line here, and I'm just going to write it again, I'm trying to prove that k squared plus 2k plus 1 plus k plus 1 is divisible by 2. I'm just going to replace the k squared. So that k squared I'm going to replace with 2m minus k. And then I still have this plus 2k, and then plus 1 plus 1. Well, actually, let's write it fully. Plus 1 plus k plus 1. So I've replaced the k squared with a 2m minus k, and then I have the 2k plus 1 plus k plus 1. I'm going to tidy this up, so this is 2m. 2k, well that k and that k cancel, so it's plus 2k, and then plus 2, and you end up with the same thing, and we can factor out the 2, so 2 on m plus k plus 1, and we get the same result. That's clearly divisible by 2. So 2 different ways to finish it. When we take the assumption, we can either try and isolate one of the letters like I did on the right hand side and sub that into what I'm trying to prove, or I might spot that there's no need to isolate one of the letters. I could just sub it in as it is. Now again, clearly I could have come down here and written this in different ways. I could have written this as k squared plus, let me see, 2k plus k plus 2. I could have written it as k squared plus 3k plus 2, and then this is what this line would have been, and I would have had to try and replace the k squared with the 2m minus k, and I still would have got it out. I would have got that 2 as a factor of it all. So different ways to finish it.